Hello and welcome to this final webinar within the Flexisoft webinar series. In this webinar we'll be looking at a Robot Palletiser application. So my name is Ian Keatley-Smith. I'm one of 3 functional safety engineers at SICK in the UK. The other 2 are Seb Strutt and Martin Kidman. We also have a number of sales guys who are also trained up to functional safety technician level. So rest assured, whenever you're talking to anybody at SICK with regards to machinery safety, they have some knowledge and some experience of that topic. So the agenda for today is first of all to understand the application and have an introduction to that. It is a video application which shows the Robot Palletiser, so we'll talk through that. Then we'll look at building up the safety solution, so we'll be looking at the inputs and outputs that are required for this application. We'll then be looking at the Flexisoft hardware that we need to make this application successful. We'll then develop the code. We'll look at simulating that code to make sure that it all works okay, and that forms part of the validation plan. We'll then look at the report that's generated from Flexisoft Designer. And then finally we'll look at where we get more information from, and we'll then have a summary of the webinar series that have gone before this one. Just to let you know, all the webinars have been recorded and they're all available from the SICK website, so just go to sick.com and navigate to the webinar page and you can request to get all of these videos. If you are struggling, then by all means get in touch with us via email or telephone. Our details are at the end, so you can get those. So first of all is an introduction to the application. So what we have here is a robot doing a palletizing task. So the boxes come along and they go underneath the light curtain and the robot then palletizes. So there's 2 areas that you can palletize, the left and the right. At the moment we're palletizing on the right, and you can see there's a physical door there protecting anybody from getting injured from the robot, and we have a number of safety devices attached onto this application here. So we're using a combination of laser scanners, safety door switches, light curtains, and we're also using the Flexisoft controller. So this is showing you a typical application. So you can see that the operator is bringing an empty pallet into the left hand side. As he pushes that pallet in, you'll see the field changing in the scanner, and the robot goes into reduced speed mode. He then leaves the pallet behind, pulls his pump truck out the way, and then the robot goes back to full speed. If for any reason there's a problem, we'll see this other. So at the moment here the guy's coming in, he is now taking away a full pallet, and you can see the robot is continuing to palletize on the other side. So this is all normal operation. So he takes that pallet out. If he walks into the area while the robot is operating and tries to gain access here, you'll see the robot slows down. So by slowing down, we're obviously reducing the safety distances as well. So it goes to slow speed. If he then just turns around and walks back out again, then the robot will resume normal operation and run at full speed. If he walks in again, the robot again goes into slow speed. But if he breaks this light curtain that's protecting the robot goes into stop straight away, and in exiting the cell he then has to press a reset push button to get the robot back up and running again. So that is the application that we're going to do with the Flexisoft. So coming in to look at the input-output requirements, so here's an image again of the robot cell. Up at the top here we have what's called an STR1 non-contact safety switch. We have an e-stop and reset combination here. We have a laser scanner protecting the floor area on the left hand side, another laser scanner protecting the floor area on the right, another e-stop and reset, another STR non-contact safety switch, and then we have our 2 internal light curtains protecting the area. So that's all of your input devices. All of those input devices are then wired back into the Flexisoft controller, which is highlighted in the center here in the middle of the machine, and ultimately what we're controlling is the robot operation. So Just bear in mind that this, what you're about to see, is a program that has been created based on this video image. It may not necessarily cover all of the functions, safety functions on the machine, but it's just to show you how a program is put together, and it should only be used for example only. Right, so now that's covered, let's go in and look at the Flexisoft hardware requirement. So we'll just keep the image up there in the left there, just to keep a visual sort of view of the application. And what we're going to have here is a Flexisoft CPU 1. So if you're not familiar with the Flexisoft controller, then go back and watch webinar 1, which goes through the hardware. But what we've got here, as you can see highlighted with my cursor, you have the memory plug, which has got 24 volts and 0 volts wired into it, and this is where your configuration is held and all your application data is held. That, when pushed into the CPU, powers up the internal electronics, and it also powers up the backplane, which powers up the electronics of the modules that are attached onto the side. At the front here we have our familiar programming port, which is just an M8 4-pin connector. We have a number of LEDs, so MS stands for module status, so if that is solid green then the code is running. If it's flashing green then it means the code isn't running. CV stands for code validated. Now if that's flashing, it means that if you do a power cycle on the controller, you'll have to manually connect onto here, connect into with your software and put the program into run. So once you've tested your program and everything is happy and you're happy with it and it responds correctly to errors, for example, you validate the code, and what will happen is this CV light here will go solid yellow telling you it's validated. On this CPU as well we also have what's called EFI, which stands for Enhanced Function Interface, and that is a solution we're going to use on this project. So we will end up attaching 2 laser scanners, so the laser scanner that's over here, as you can see indicated on the left hand side, and this laser scanner on the right hand side will be wired into these EFI ports. And the advantage of that is, from a wiring point of view, it's just a twisted pair wire going down to one laser scanner and power, and the second scanner again just a twisted pair wire. So that covers the CPU. The XTIO here has got 8 digital inputs and 4 digital outputs. So let's start adding on the hardware into this now. So first thing we have is our safety laser scanner. So you can see them populated now onto the EFI ports. So the left hand scanner on the image is connected to EFI1, the right hand scanner is connected to EFI2. The next thing we've got is our emergency stop, and you can see that is now populated onto input 1 and input 2. And you'll also notice that X1 and X2 have got a digital symbol on there as well, and that's because we're using test pulses. So we send a test pulse out of X1 round through one channel of the E-stop back into input 1, and then X2 through the second channel of the E-stop back into input 2. So it's actively checking your wiring for shorts to 24 volts, shorts to ground, and shorts between the channels as well. So I always recommend using test pulses if you've got a volt-free contact on your input. And you'll see later on that in the report that's generated from the Flexisoft, it will show you how to physically connect those together. So that's the emergency stop. The next thing we have is our 2 STR1 non-contact safety switches. So that is a safety switch which has got 2 safe semiconductor outputs, and they're just wired directly into input 3 and 4 as shown there, and input 5 and 6. And the reason for those switches is so we know the position of the door. So in the image of the machine that you can see there, the switches are located at the top. So up here would be a door switch to indicate the door was closed on this area, and then when the robot wants to work in the left hand area, the operator simply slides the door over into this location, and we use these safety switches to determine the position of this door. We then have our internal light curtains. Now there's our internal light curtain on input 7 and 8, but we've got 2 internal light curtains. So we've now maxed out the XTIO card, and it's simple with Flexisoft because it's a modular. all we need to do is introduce a new XTIO slice, put in our second light curtain, and we're fine now. So there's our two internal light curtains. We also have a manual reset which goes in there on input 3, and on the output side we've got the robot dual channel to say it can go into fast mode. We also have the robot going into slow mode, and if the robot doesn't see either of those signals, then it goes into an e-stop condition. So that's a bit of a caveat on the robot controller. And then we have a number of indicator lamps. So we can see there we've got Q1, 2, 3 and 4 that are free, so we're going to put some lamps on there. So we'll have a lamp on there to indicate we're running at full speed. We'll also have a lamp to say we're at slow speed. We'll have one to say that we're in an emergency stop situation. And finally on Q4 it'll indicate that a reset is required of the system. So that is our Flexisoft hardware. We've allocated our inputs and our outputs. So now we need to go in and start developing the code. Now in previous webinars I've done the code, showing you how the code is put together, but the code for this is quite complicated. So rather than showing you me writing the code, what I've got here is just a image of the logic and how it's being created. So along the top there we've got various pages within the code, and whenever you're writing safety code you should always break it down into small chunks, so at least then you can get an understanding of the individual parts of the program. And as you can see here, I've also added a comment so that when I come back and look at the program at a later time, I can read the comment and understand how this logic works. So this is quite a simple one. So you get the e-stop logic. So if the emergency stop is okay, then what will happen is the e-stop reset required lamp will flash. You simply press and release the reset push button in the top left, and you will get a flag coming out there saying e-stop is okay. And I've used jump addresses for those, so you can use them elsewhere within the logic. So that's your e-stop page. If we then go and look at the robot for the left, the robot for the left and the right is the same logic, it's just the tags are different. So bearing in mind the image at the top there is showing the robot working on the right hand side, we'll jump to the right hand side logic. So if we just go through this bit of logic here, so what we're saying is that in order for the robot to run over here, if I bring my cursor over again, first of all the STR1 door right side, so this door switch here has to be closed. They also have the DTEC 4, which is a type 4 14mm resolution light curtain, and that's the light curtain that sits along here that's being indicated with the cursor just now. So in order for the robot to run, we need to have this door closed, and this light curtain here has to be clear. Over here I'm looking at the safety field on the left hand side, so I'm looking at this safety field here. If this door is closed, I'm not really interested in the field in here because it's physically protected with the door. So if this field is clear, then this will be logic 1, and what will happen then is logic 1 will come down to here, down here into this AND gate, and if my door is closed and the light curtain is clear and it's reset, this tag here will then be logic 1, so we'll have a 1 and a 1, and that will allow the robot to run at full speed. If somebody walks into this laser scanner field here, then this here will go from logic 1 to logic 0. So when that goes to logic 0, we no longer have a 1 and 1 here, we have a 0 and a 1, so we can no longer run the robot at full speed. But what we're doing with here is that when that goes to logic 0, this converts it to logic 1, which gives me a 1 here. The door is still closed and the internal light curtain is okay, so now I can run the robot at slow speed. And you saw that in the animation earlier of how the process works. So that's the logic for the robot right hand side. We then have a page which looks at robot control, which gives you the options that are available to you to make the robot, this is the final switching element here, that's the output to say the robot can run at fast speed and the robot can run at slow speed. We then have the S300 on the left side, and here is the logic. So all I'm doing here is taking the protective field, which is the red field in here, and just taking it to a jump address. And this logic here is doing the field switching. So we'll have a look at this later on when we look at simulation. The logic for the S300 on the right side is the same, and then finally we have the diagnostic lamps. So we have a lamp, a green lamp to say we're okay at full speed, we have an amber to say we're at slow speed, we then have a red lamp to say the robot is stopped. So if we don't have slow speed or fast speed, then we'll get a red lamp indicating that. And then we have various options to do the reset required lamps. So if an e-stop is resets required, if you have broken the internal light curtain that needs a reset, so you get the indication through there. As I said, this logic is nowhere near complete, but it'll give you an example of how it should be laid out. So moving into the simulation phase, what we're going to do here is look at the laser scanners. So this is the scenario where the person walks in and is depositing a pallet, and how the field switching is done. So as I mentioned earlier, the laser scanners are connected onto this FE port, so you can see them down here. And if I double click on the left hand scanner, just as an example, I will now bring over the configuration window for that. And how we switch it is via a software input. So this is coming from the CPU. We're going to use input A on here. I then go to field sets, and you can see I've got two field sets which are selectable there, which I've drawn. So you've got one where the pack guy comes in. Now I need to set the cases. So here, if A is 0, I'm going to select field set 1, and when A is 1, I'm going to select field set 2, and it's that simple. Now if I go into the simulation here, you can see I've got the A input, and as I press it and release it, you can see the fields changing. So it's quite a useful tool, this, to make sure you're selecting the right fields. Looking at the logic that controls that, if we come over and we look at the S300 left side, say that's your protective field, your safety field, and this is the logic that's changing the field. So you'll see later on when we watch the video, we're just going to simulate this. When the warning field is broken, then you get this scenario. When the warning field is clear, you get this. So when you watch the video, you'll understand that the warning field is the field that's doing the switching. So just to visualize that, what we'll do is we'll run the animation of the operator coming in with the pallet. So there's the warning field, which is the yellow one, and you'll notice that as soon as the pump truck hits it, it switches. So that's what we're doing in the software. We're using the warning field to switch that, and then as he comes back out, it changes state. So hopefully that's understandable. When you're looking at field switching and things like that, anyone who's got a keen eye will have noticed we're just using the A input. You can have many fields being switched, and that's where the simulation comes in handy, because you need to make sure that when you select the case that you get the right fields. So that covers the scanners. So let's go in and look at the logic here. So as I mentioned, we've got our e-stop page, we've got our page which looks for the robot left hand side, our page for the right hand side, we've got the robot control page, we then have the logic that you've just seen for the S300 on the left side and with the right side, and then we have our lamps. When it comes to simulating this, the best place to go is the I/O matrix. So what we have down the left hand side here is all the inputs that are able to be switched, and then all the associated outputs as well. And in the middle here we have a graphic which shows you the relationship between those inputs and those outputs. So what we're going to do now is simulate this logic to make sure it works okay. So what I'll do is just come back into here, and we will just remind you of the application again. So the robot is palletizing there. So under normal operation, the operator comes in and takes the pallet away. So everything's fine there, everything's working as normal. If the operator walks in, so you see the robot's working at full speed, if he walks into that area there, the robot goes into slow speed, and then if he turns round and walks straight back out again, then what will happen is it will automatically switch back into fast speed and work it there. The operator now walks in, the robot again goes into slow speed. Now if he breaks that internal light curtain, the robot will then stop. It will require him to walk out and press the reset push button to get the process running again. So we just need to make sure that the logic that's been written works in that manner. So let's come into here, there's your picture. So let's go into the simulation, and what we're going to say here is that the e-stop is healthy. The door is on the left hand side, as you can see indicated in the image. The right hand side light curtain is clear, and we're now going to say the scanner is clear. Press the reset, and up there at the top you can see robot fast speed. Now as soon as he walks in, he's going to break that laser scanner, and then the logic changes, and you can see it's changed now to say robot going to slow speed. Once he clears that area, it goes back into fast speed again. So that's working okay. Now if he walks in to the field, it goes into slow, but he then breaks the internal light curtain, then what will happen is we lose that and the robot goes into stop. So it's no longer got a valid signal. He comes out of the light curtain, out of the protective field, he can then reset, and the robot can now run back up at full speed again. So that's just simulating the process. So hopefully that makes sense. It's trying to get what you have to do is work out how to write the logic before you actually write it. So you need to have almost like a truth table like this of how you want the relationship to work. So that's simulated the logic, and we're now quite perfectly happy with that. Now, as well as simulating it in working conditions, you'll also simulate it in fault conditions as well. So you would have quite a extensive validation and verification test schedule for something like this application. Coming into the reporting side of things, up at the top here within the software, you can see you had your hardware configuration, your logic, your CPU, then you come to report. If you click on the report there, it will generate the report for you, and this will give you a list of all the part numbers of the hardware that you're using. If we then scroll down, you've got the general information, and this is where you've got your unique CRC checksum, the configuration state and the configuration date, which are both vital for your technical file. There is your e-stop logic, there's your robot left hand side logic, robot right hand side logic, the robot control, putting into slow and fast mode. Then we have the scanner logic for the left side and also for the right side. And then if we carry on down, you get to see how it's physically wired. So this is your wiring diagram for your scanners. Coming down, you'll see the wiring diagram for the first XTIO, and there is your X1 and X2 showing you the test pulses, how that should be wired for your e-stop. There's your second XTIO, and the good thing is, because the scanners are connected to the EFI port, it pulls in all the configuration of the scanners as well. So here you can see that we've got all the field sets within the report as well. So it's an all-encompassing report really, it's got everything that you need. So that report would, as I say, would form part of your technical file, and if ever there was an accident on the machine, at least then you could bring up this report and be able to easily identify if there's been any modifications done to the machine since it was installed and commissioned. Now, where to go to get more information on all of this, and there is the SICK website. Simply go to sick.com. It says I am looking for, just type in Flexi. That will take you to Flexisoft landing page, just as highlighted in the video here. And then you've got areas where you can get access to all of the components for Flexisoft, and within there you'll find all the manuals and things as well that are available to you. If you're interested in the robotics side of things and safe robotics, we have a number of applications involving laser scanners and robotics. So this is just one being shown here with the safe area protection, and we do it as a bundled hardware kit, so you can get the software separately and buy the hardware separately. It's entirely up to yourself. So that's the best place to go to if you want more information on the Flexi and our robotic applications that we have. The other option is to go to YouTube. So we have a dedicated SICK YouTube channel, so just type in SICK Sensor Intelligence, and I recommend that you subscribe to it and click the bell notification for any new videos that are coming out. Simply search for Safe Robot, hit return, and it will show you videos of our safe robotic applications which help you visualize how the software in Flexisoft and the packages all work together. Type in Flexisoft and you'll have access to loads of videos on Flexisoft. So there's one there, you can see there's a 10 next to it, so there's a 10-part series that goes through the entire Flexisoft Designer software, which would be useful if you're new to Flexisoft. And then we have dedicated videos for other aspects of it, which are things like Flexi Loop, Flexi Line. It's all there for you. So just going through a summary of the webinar series. If you haven't been on any other webinars, these are all available to download and watch on demand. So webinar 1 was an introduction to Flexisoft, and that looked, it's quite a basic introduction if you've never used Flexisoft before, and that goes through all the hardware options that are available to you and touches briefly on the Flexisoft Designer software. And for those that have never used it, it's a free download for the software. So just go to that SICK website, type in Flexisoft Designer, and you'll get a free download link to get that. Webinar 2 looked at the function blocks within Flexisoft Designer, and there are many function blocks within Flexisoft Designer, but I just picked out the main ones that we tend to use. And it also shows you that there's an information tab for every single block in Flexisoft Designer, which is an extract out the user manual, so you don't have to go digging through manuals trying to work out how the blocks work. It's all built within the software. For webinar 3 we looked at Flexi Loop, and Flexi Loop is a system where we have remote I/O, and that comes back into the Flexisoft, so it reduces the number of Flexisoft slices that you need, but it does work best when you've got a diagnostic card, so that's all covered in Flexi Loop. Webinar 4 looked at Flexi Link. So Flexi Link is connecting multiple Flexisofts together. So Flexi Link allows you to connect up to 4 controllers together, and it's connected using what's called this EFI, Enhanced Function Interface port. Webinar 5 looks at Flexi Line. Again, it's very similar to Link. It's connecting multiple CPUs together, but rather than connecting 4 CPUs together, in Flexi Line we can connect up to 32 CPUs together, and they can be 1 kilometer apart, each one. So you're looking at going huge distances. So Flexi Line covers that. Webinar 6 looked at diagnostics, and in that one we looked at how you got diagnostics from the Flexisoft back to a Rockwell Control Logics PLC, and goes through all the other controllers that we can connect to and all the diagnostic cards available. And this is webinar 7 that you've just watched, which is the example machine of a Robot Palletiser. So that concludes the 7-part webinar series on Flexisoft. I do hope you found the series useful. As I said, there's a lot more information available on the internet through our website and also through the YouTube channel. But if you do have any questions at all, then my details are down at the bottom left there. So as I said, my name is Ian Keatley Smith. There is my email address and my mobile telephone number, and Martin's details are there as well. So Martin is based up in the north of England. I am based down in Worcester, which is just south of Birmingham. So between the two of us we cover the whole country, but usually Martin deals with the northern inquiries and I deal with the south, just to keep our travelling down. So as I say, I hope you found it useful. Thank you very much for your attention, and that now concludes the webinar series. Thank you and goodbye.